In question 6, it says use the graph of the equation to find all the factors and zeros of the polynomial. So we have two things we got to do. We have to find zeros, and we also have to find factors. So what we're going to do is the first thing we're going to do is we're going to use this graph and help us find a very specific point. This point right here, when x is a -4, that's a biggie because it is tangent to the graph. Tangent means it touches the x-axis but doesn't cross it. It means you can use it twice in your synthetic division because it's a double root, double zero, double solution. So what we're going to do is we're going to set up our synthetic division. We're going to divide by -4. We're going to divide into our coefficients of a -1, -4, 3, -40, and -208. We're going to drop down our -1, and we're going to take a -4 times a -1, which is a +4. That gives us a 0. We're going to take a -4 times 0, which is 0. We're going to add it to 3, which is a 3. A -4 times 3 is a -12. Add it to a -40 is a -52. They're going to take a -4 times a +52, or a -52, which is a +208, and we get a remainder of 0. And that's what our graph is telling us, is that a -4 is a solution. But -4 is a solution multiple times. It's a solution one more time, so we use it in our synthetic division twice. That point of tangency tells you to go twice with the same number. So drop down your -1. -4 times -1 is a +4. Added is a 4. -4 times 4 is -16. Add together, it's a -13. -4 times a -13 is a +52, and you get a remainder of 0. And now we've got this depressed. It used to be a 4th degree polynomial up here. We got a remainder of 0, became a 3rd degree polynomial. We got a remainder of 0, now it's a 2nd degree polynomial. And that's when we stop using our synthetic division. From our graph, you can see there aren't any other real zeros, so the rest are going to be complex. So we got to take this equation here, the one that says a -x² plus 4x minus 13, and we have to find the zeros of this remaining 2nd degree polynomial. I'm going to go right into the quadratic formula to find those. So x is going to be the opposite of b, which is -4, plus or minus the square root of 4 squared, which is 16. Then it's going to be minus 4 times a -1 times a -13, which are 3 negatives. So we got a -4 times a -1 times a -13. That's -52. All over 2 times a -1 or -2. Now there's some simplification that has to happen in here. It's a -4 plus or minus the square root of 52 minus 16 is -36 all over -2. Now it's a -4 over a -2 plus or minus the square root of -36 is 6i over -2. This ends up being a +2 plus or minus, and then you could put a -3i. There's no reason to keep all these double signs in here because plus a negative is negative, and negative times a negative is negative. So really it can just be simplified to 2 plus or minus 3i. Those are my other two zeros. Okay, so now we've located all the zeros. One of the zeros that we get to use twice is a -4, -4. You can list it once or twice, doesn't matter, it's a double root. The other roots that we found were 2 plus or minus 3i, so 2 plus or minus 3i. Now, to get from zeros to factors, we just looked at this. We say, well, if x is a -4, if that's my 0, then x plus 4 is the 0, or the factor for that related 0. So we have two of those in our solution. We have an x plus 4 times another x plus 4. And we also know from our solving that these zeros of 2 plus 3i, that means x is a solution when we have a 2 plus 3i. We want to set this equal to 0 so we can get the factor x minus 2 minus 3i equals 0. That's another factor, so I'm going to put that one over there, x minus 2 minus 3i. And then we also have to go through with our third answer, which was when x is equal to, I'm getting it from this part right here, 2 minus 3i. So if we set that equal to 0, it's going to be x minus 2 plus 3i equals 0. There's your final factor that you're looking for. So you know, run a little bit out of room, so x minus 2 plus 3i. These are the related zeros to these factors. And the minus 4, there's your related zeros and the factors.